Hey guys, today's video is going to be really exciting. We are going to talk about anomaly detection, which falls under unsupervised machine learning technique. Anomaly detection is a crucial aspect of data analysis, and it helps us identify rare and unusual occurrences which you see in the datasets. This video will answer some of the frequently asked questions, such as what machine learning type does this anomaly detection belongs to? Second is, which algorithm can be used for anomaly detection? And lastly, what are the three basic approaches to apply anomaly detection? How do we really implement this anomaly detection? So stay tuned and make sure to watch this video till the end, and let's get started. Hey guys, welcome to AI with AI. This side Asif Imnad. To understand where are we in this journey under machine learning techniques, we have tons of videos already created under supervised learning, classification and regression, with the hands-on, with the demo. Make sure you watch those videos if you have not yet. And we are under unsupervised learning now, where data is not labeled. This is what we are currently learning. And in the recent videos, we have seen the clustering techniques, that is K-means clustering. Now we are again under unsupervised learning technique, which is anomaly detection, which you don't see it here. Dimensionality reduction and association, these are the different types of unsupervised learning we are going to see in future. But we have one more thing, which is anomaly detection. Basically, anomaly detection is a technique, is a concept which can be implemented by many algorithms which we have already studied, like SVM and K-means. First thing first, what is anomaly detection and why it is important? Let's understand with a real life example. Have you ever thought about bank where you make several transactions? How does bank detects the fraud which happened? So what does these bank managers are looking for? So these bank managers are actually notices unusual behavior in your accounts. They are looking for how do you spend. They're looking for if you're spending a lot of amount in a day which you haven't done in the past, and you frequently doing the unusual spendings at different locations. So this is unusual behavior. If this happens, we see a sudden message coming as an alert so that we can block our card, or if we can report this activity or block our card immediately. Just to give you a more example which is really used in the industry already, let's say you are doing online shopping on any famous e-commerce website like Amazon, Flipkart, or any other Shopee or eBay, so on and so forth. So you're doing a shopping on the special occasions, on a special events like Black Friday sale, like Christmas evening, like New Year sale, or Big Billion Day sale, or Amazon festival sale that we have in India. What happens during this event is there is a lot of sudden spike that we see at certain time, right? After 12 o'clock, immediately we see a sudden spike. Sudden lot of people start using the website and start purchasing the products so that it won't go out of stock. And you might have also observed that. So for a particular period of time, you might see some lags, some latency lag, some problem with related to the product that you are purchasing. And such activities are continuously monitored. Just to understand the situation, on a usual day, 1 million traffic is coming to the website, but suddenly, because of the sale event going on, limited period of time sale, we see a sudden spike, sudden traffic coming to the website, which goes from 1 million to 100 million as well. I don't know. So if that happens, then that's an unusual activity. So currently in this situation, the companies are already prepared. So they have the load, they have the machines, they have scaled their servers already to handle that much amount of bandwidth or a traffic. But let's say on any usual day during night times, the traffic that we expect is 1 million, but suddenly we see 100 million, which is unusual. And there is no special event, there are no sales going on, but still why do we see rather than 1 million, 100 million traffic on the website? And this is called unusual activity, and anomaly is identified here. This could be because of someone is trying to hack the system, or someone is trying to brute force and try to bring the servers down by putting the huge load on the servers. And imagine if this happens with the big giants like Amazon or Facebook. And hence anomaly detection is really crucial in case of banking, to detect the fraudulent transaction, to detect the unusual activity, diseases detection, or handle any other case studies with high class imbalance. Generally speaking, an anomaly is something that differs from norm. So this is a norm and this is an anomaly. A deviation, an exception. In diagram you see this is an exception, right? This is a norm, but this is an exception. Formally speaking, anomaly is nothing but a rare occurrence or event that doesn't fit into the pattern. this doesn't fit into the pattern and therefore seems suspicious. Anomalies are the data points that stands out among other data points in the dataset and do not confirm the normal behavior in the data. So this data point does not confirm the normal behavior in the data. This is what anomaly is. If you see the data point placement and not the color, this is not anomaly, right? This is normal behavior. There is no deviation, there is no exception. But if I see this is a deviation, this is not normal, so this is an anomaly. Alright, very simple to understand, right? Now let's proceed and understand what are the different types of anomaly detections are and how do we really implement anomaly detection. But before we proceed and discuss in detail, if you are new here, don't forget to hit that subscribe button and bell icon so you won't miss our latest videos on AI. We see you're watching our videos, but 90% of you are not yet subscribed. We put a lot of efforts creating videos for you free, so keep us motivated by liking and subscribing so that we keep doing this and YouTube algorithm will help us reach more audience. So did you subscribe and like? If so, thank you. Now let's talk about the different types of anomaly detection. There are three major types of anomaly detection. The first one is global outliers or point anomaly, basically the example which I have shown you in the diagram. So these are just the individual data points that are significantly different from rest of the data. So this data point is different than the normal, right, other data points. So this is called point anomaly or a global outlier. So this is an outlier, right? This is not usual. This is 1 in million. This is 1 in 1000. This kind of activity generally happens during fraud and credit card transactions. Okay, very simple. The next type that we have is a contextual anomalies. Anomalies are context dependent as well. They may not be a place dependent, but they can be a context dependent. Meaning they might not be anomalous in all the situations, maybe by the time, by the place. Just to give you an example, during end of season sale, we see a lot of traffic which comes to the website. But during night hours, we see a sudden drop in the website traffic, which is not anomaly. So this is called contextual anomalies. Then the last but not the least is called collective anomalies, which is nothing but a group of data points together forms an anomaly. It is not a one data point, it is not a contextual, but it is collective. It is group of data points together forms an anomaly. For instance, you can say unexpected spike in the server response times affecting group of users. So here it is not about one data point or one anomaly, it is affecting group of users. So it is collective anomalies. Okay, now if this is very much clear to you, let's proceed to understand how do we implement anomaly detection. What are the common methods used for anomaly detection? Again, this question is very much asked in the interviews. There are three methods: statistical way, machine learning method obviously, and time series analysis. Statistical is basically using some statistical matrices such as mean, median, mod or standard deviation, so on and so forth. Basically by calculating the distance and the deviation of the data points that falls outside the boundaries and can be considered as anomaly. It's very simple. I'm going to talk about one of the method in the next slide, so be with me, which is really interesting. The second type is definitely machine learning methods. We already have a lot of algorithms which will help us identify the anomaly. The very first most popular algorithm that is used is isolation forest. Then we have one class SVM, which is one class support vector machine. We have already seen support vector machine under supervised learning, but this is one class support vector machine. We are going to understand these algorithms in future videos, so don't worry about these for now. And we also have one of the algorithm which is called autoencoders. These are the algorithms which are widely used for anomaly detection. And finally, we have time series analysis. This method is particularly used for detecting anomalies in temporal data. When I say temporal, that means time-based data, like stock prices, like temperature, which changes based on the time. Temperature rises during mid of the day, temperature goes down during end of the day, and it might drops to the freezing cold in midnight, right? So this is seasonal data, right? That's why we call this as time series analysis. By using this technique also, we can detect anomalies. Let's see one of the way by which we can detect the anomaly, which is nothing but Gaussian kernels. This is one of the method, Gaussian kernels, which will help us identify anomaly data points, anomalies basically. We know the kernel already. What do you mean by kernel? If you remember from our past videos, during SVM we discussed kernel. If you see in the diagram, we have two-dimensional data. Separating this data in two dimension is very difficult. by drawing a line, right? So this is not linearly separable data. I cannot draw a line and separate the data, right? Orange and green cannot be separated by drawing a line. So that's why I'm using kernel. So I see the data in different dimensions. I have 3 dimensions now. So when I see the data in different dimensions with the different angles, I see these green ones are not really mixed with the orange ones. These are at the bottom and orange ones are at the top. But I understand this when I look at the data from different angle. And this is where I can draw a plane, draw a line and separate the data. Basically, it will be a plane if it is in 3 dimension, and in 2 dimension we call it as a line, but this is a plane here. By cutting the data points with the plane, we'll be able to separate the data, and this is what the kernel stands for. So Gaussian kernel looks something like this. This is called bell curve. So we can use this bell curve or a Gaussian kernel to detect anomalies. How? Let's see in the next slide. So we need to design our Gaussian kernel in such a way that now if I see this Gaussian kernel in 2 dimensions, this is how it looks like. A bigger Gaussian kernel looks something like this from the top in 2 dimensions, right? So at the center we have most closed data, and as we go away from the center, the circle becomes bigger and chances of anomalies are also bigger. You can easily say that smaller the Gaussian kernel, high chances of having more anomalies. If we have bigger kernel, but chances of detecting anomalies could be less. So we need to identify which hat. Gaussian kernel is also called a hat because it looks like a hat, right? So we need to also identify what size of this Gaussian kernel is actually identical for our data. Let's see this in the next diagram. If you see in the diagram, again we have the data points which are drawn against x1 and x2, something like this as you see in the diagram. Now let's say we want to identify a new data point which is coming here. Let's say this is a new transaction which is happening and the data point placement comes here. Now we need to identify if this is an anomaly or no. So how do I identify that? The one method I told you is a Gaussian kernel. So Gaussian hat, that hat I will drop on this data, something like this. If I drop this hat or a Gaussian kernel, which we have seen here in the 2 dimension, I drop it here in the diagrams. So by identifying the mean and the deviation, I can easily predict if this data point is anomalous or no. Currently this data point falls under the circle, so I don't think this is an anomaly. Now let's see another situation where next data point is coming here. So this is way far from the normal data points. Visually I can easily say it is an anomaly, but how do machine identifies that? So machine will drop a Gaussian hat on the data point and it will check, does this data point within this circle and what is the deviation, how far it is from the normal data points. So by looking at the distance and the deviation, it is not falling under the circle. Machine can easily predict that new data point which has come is a fraudulent transaction or it is an anomaly. Alright, so I tried to explain anomaly detection with a really simple example so anyone can understand, even a beginner. For now, let's conclude this video. In the next video, we will see how to implement anomaly detection. For now, just to conclude this video, I can say anomaly detection is identifying a data point in a data that doesn't fit the normal pattern. It can be useful to solve many problems including fraud detection, medical diagnosis, intrusion detection, etc. Machine learning method allows to automate such anomaly detection and make it more effective, especially when we have large data sets. And we have also seen some of the machine learning methods which are used in anomaly detection are isolation forest, one class support vector machine, autoencoders and clustering. For sure we are going to talk about these algorithms in future videos, but for now this is it, and that's how we come to an end of this video. If you have any questions regarding the same, let us know in the comment below. If you found this video helpful, please subscribe to my channel and hit that like button. And yes, don't forget to share this video with your friends and your colleagues. Thanks for watching. See you again next time. Till then, take care and bye bye.